Okay, as part of our discussion of the cell, we're going to cover homeostasis and feedback mechanisms really quick. As we have discussed already, homeostasis is a constant balance that we have internally within our cells, within the chemistry of the body. We're always trying to find that equilibrium, and that's really, really important because the fact of the matter is, in terms of the work that you're going to be doing in healthcare and science, you're going to be studying organic systems all day long. You're going to be working with human beings, and the body can heal itself. So that's the whole point in understanding this information. Here we've got a dude balancing on a seesaw here and trying to find that balance however possible. And sometimes, the balance will shift this way, and other times it'll shift back the other way. But the whole idea is to maintain a relatively steady state within the cell. And as you can see, this guy's got a little quivering leg muscles here, and arm muscles. It takes effort, but it's well worth the effort. Here's an overview of homeostasis and feedback. So we want to have that balance within the body. It's achieved via different ways. All right. So the brain, we all know that the brain is like our hard drive, right? It controls everything. Every cell within your body is either directly or indirectly innervated or powered, controlled by the nervous system. And so the brain is at the root of all of this stuff. The brain will make conscious decisions, and within the spinal cord, that aspect of the central nervous system, there are reflexes that occur. So let's say if we detect that your oxygen levels are low within your cells, there are actually little reflex nerves that will tap into your blood vessels and tell us, okay, they'll sense within the circulating blood that the oxygen is low, we need to boost it. And there are various methods so we can do that. Working with the lungs and the kidneys, all the systems working together. So if, let's say, your oxygen, we're going to go into this a little more detail later, your oxygen in your blood vessels is seen to go down. There's a nerve that comes out into that blood vessel and tests the status of the red blood cells and says, okay, the oxygen's down, we need to boost it up. There'll be some changes that happen on the cellular level in order to change that and help us heal. That is called a reflex. Simple model of an illustration of homeostatic regulation. There's a receptor in that, that would be the nerve, that the receptors attached to the nerve, tapping into the blood vessel, that's going to sense a change, and then there's going to be a relay to a control center, and that's going to say, okay, we've got something going on here, we need to, blood gases are low, we need to boost oxygen, and then it'll send a message to what's called an effector that would take actions to change that. And then there's the variable that in the body, it can be modified by the effector, its response essentially. So we can also, somewhere in this slide, is probably the most easy to understand image, and here we go, a thermostat. So you are in your house, and now it's the dog days of summer. It is hot as hell outside, and that's transferring inside. Here's the control center on your wall. It's a thermostat. So the receptor is going to, or the thermometer within the thermostat is going to say, oh my God, it is hot as hell in this house. So that's going to trigger this thermostat. That's going to say, the message is going to be received that it's hot as hell, and then the thermostat is going to say, okay, we need to send a message to the air conditioner, and the air conditioner is going to kick on, and you'll hear it, thankfully, right? because we all need to sleep when it's nice and chilly, nice and cool, and we can bundle up with our comforters and all that stuff. So it's hot as hell. Thermostat detects it. It sends a message to the air conditioner. The air conditioner turns on, and the room temperature goes to an acceptable level, and then the air conditioner will switch off, and everything is balanced. Right? Here's a little line drawing, a little graphical analysis of this as well, where the temperature starts to rise in the house. Thermostat clicks on, says whoa, and then it'll decrease that. So the net is going to be balanced right here, and that is called a feedback loop. We've got feedback loops within our body. Okay, so there's different types of regulation. There's intrinsic and extrinsic regulation. So intrinsic regulation is where the cell, tissue, or organ or system, it's going to automatically adjust in response to a change. So each cell in your body is capable of performing this intrinsic auto-regulation just on its own. Extrinsic regulation is going to be where there are actually nerves and excuse me, hormones involved. And this complicated graphic is going to show you how all this happens within, let's say, a damaged blood vessel. All these different chemical factors are at work doing its thing, and there's going to be a clot, and yeah, and then in the extrinsic, that's the intrinsic pathway. In the extrinsic pathway, there's sufficient trauma where nerves are going, it's beyond chemical now, and nerves within that area are going to sense, wow, we've got a bleed here, this blood vessel wall is damaged, we need to take action. And so rather than just chemistry, auto-regulation, we will actually have clotting and smooth muscle action within the blood vessel wall that will aid in the healing process. There's negative feedback and positive feedback loops. Negative feedback is the most common type of feedback that we are going to have going on within the human body, and it corrects by opposing the imbalance. So that is your thermostat model of action. A positive feedback, a good example of that, is where there's going to be an exaggerated change in the direction of variation. So when a mother is having contractions during labor, the contractions don't become lesser, they become greater in order to expel the fetus. So this is a little bit less common, and it tends to be very dramatic. Negative feedback is more common and is happening all the time in the form of that intrinsic and extrinsic feedback, the thermostatic model. And here's a nice image below here that it gives us an example of, in terms of temperature is the variable here. We've got normal body temperature, 98.6, and then the temperature rises in the case of a fever. There's going to be temperature sensors in the skin, there's going to be sweating, and that's going to reach an area in the brain called the hypothalamus, which is going to take actions to reduce body temperature, again via sweat glands and dilation of the blood vessels, in which case the temperature is going to go back to normal. Big take-home message here is that there is teamwork that occurs within the body's systems regarding homeostasis. So that constant steady state is trying to be achieved. We've got all of the different elements here connected via the nervous system and the hormones within the body, which what you'll come to know as the endocrine system, and they are all communicating at all times. And there's no single system that has complete control over the body's internal environment. These different elements are going to work together in order to maintain homeostasis, and we're going to examine the different ways by which they do that going forward. Just a quick overview of homeostasis and feedback. Homeostasis is that steady state, constant state of internal balance that your cells, your chemistry, all levels of the hierarchy of human structure and function are trying to be achieved. Homeostasis is what keeps us alive. Think of the thermostat model of the temperature rising within your house, the relay going to the thermostat, which kicks on the air conditioner, which reduces the temperature and makes you cool. That is negative feedback, a negative feedback loop. Also, you gotta understand that all the organs and systems within the body are going to work together in order to achieve homeostasis. And there are two types of homeostasis: intrinsic and extrinsic. Have a good day.